Chapter 8, Lesson 7, Solve One-Step Inequalities. Our content target, students will understand that one-step inequalities can be solved using algebraic properties. Our language target, students will demonstrate their understanding by solving one-step inequalities and graphing the solutions on a number line. As in Lesson 6, we want to make sure we remember that the open circle on our number line is for greater than and less than. And for closed circles, it is for less than or equal to, greater than or equal to, or equal to. So to solve an one-step inequality, we need to get our variable by itself. So we have x plus 7 is greater than or equal to 10. So x plus 7 is greater than or equal to 10. In this situation, I'm going to get my variable by itself. So I have add 7 on this side, so do the opposite would be to subtract 7 from both sides of my inequality. 7 minus 7 is 0. They cancel out. I'm left with x. 10 minus 7 is 3. So then I bring down my sign of greater than or equal to. So x has to be greater than or equal to 3. So I find 3 on my number line. It's greater than or equal to. If it's equal to, that means it has to be a shaded in circle, closed circle, and it has to be all numbers greater than or equal to 3. So numbers that are greater than 3 are 4, 5, 6, etc. So I have to draw my line or my arrow to the right to show all numbers greater than 3. When I look at the next one, solve x minus 3 is less than 9. Graph the solutions on a number line. So again, the same thing. X minus 3 less than 9. So to get my x variable all by itself, I have to do the opposite of subtract 3, which is to add 3 to both sides of my inequality. 3 minus 3 is 0, so they cancel each other out. I'm left with my x value is less than 9 plus 3 is 12. So the value for x is all numbers less than 12. So here's 12. I put my circle around it. Notice it's only less than. There's no equal to, so it's an open circle. And I need all numbers less than 12, which would be 11, 10, 9, and etc. So then I draw my arrow to the left, showing all numbers less than 12. So I have n plus 2 is less than or equal to 5. Again, to get my variable by itself, I have to do the opposite of add 2, which is to subtract 2 from both sides. 2 minus 2 is 0. Those cancel out. I'm left with my variable n is less than or equal to 5 minus 2, which is 3. So again, I find 3 on my number line. I put a circle around it. Less than or equal to sign is there. So this is a closed circle. Anytime it's equal to. And I need all numbers that are less than 3. So 2, 1, 0, even the negative numbers are less than 3. So my arrow points to the left. Y minus 3 is greater than 9. So again, y is what I want to get by itself. So I have to do the opposite of minus 3, which is to add 3 to both sides of my inequality. 3 minus 3 is 0. I'm left with y is greater than 9 plus 3, which is 12. So again, I find 12 on my number line. I put a circle around it. It's greater than, it's not equal to, so it's an open circle, and all numbers greater than 12. Numbers greater than 12 would be 13, 14, 15, and etc. So then I draw my line, my arrow to the right to show all of the numbers greater than 12. Now we can also do this with multiplying and dividing. So again, think opposite. So when we solve 5x is less than or equal to 45, I'm thinking 5 times some number is less than or equal to 45. So to solve this, I have to do the opposite of multiply, which is divide. I'm going to divide each by 5, by that coefficient. 5x divided by 5, the 5's cancel out. I'm left with x is greater than or less than or equal to 45 divided by 5, which is 9. So x is less than or equal to 9, so I go to 9. I put my circle around it. Less than or equal to, it's equal to, so that means 9 is a solution. All numbers less than 9, so that's 8, 7, 6, 5. So I've drawn my line or my arrow all the way to the left to represent all numbers less than 9. So if you have multiplication to solve to get our x value by itself, do the opposite, which is to divide. If I have a division inequality, such as solve x divided by 8 is greater than 3, I again have to do the opposite, which is now instead of dividing is to multiply. So I have 8 divided by x is greater than 3. So I want to multiply to get x by itself. I have to multiply by the denominator, which is 8 over 1. I do the same thing over here. I multiply by 8 over 1. Which would be, these two numbers will cancel out. I have x is greater than 8 times 3, which is 24. And let's just say we change our numbers here. This would be 24, 25, 23, 22, 21, 20, 19. So I would find 24. I'd put my 0 around it, or my circle around it. It's greater than 24, so it's open circle. It's not equal to. So I need all the numbers greater than 24, which would be 25, and all the numbers to the right. So when we look at the last two examples, 10x is less than 80, so that's 10 times x is less than 80. So to find and solve, I have to do the opposite of multiply, which is divide. So I divide each by 10. 10x divided by 10, the 10's cancel out. I'm left with x is less than 80 divided by 10, which is 8. So x is less than 8. So I go to my number line. I find 8. I put my circle around it. Less than, so I know it's an open circle because there's not a line underneath. And all numbers less than 8, which would be 7, 6, and 5. So I draw my arrow to the left to show all numbers less than 8. On x divided by 6 is greater than or equal to 7. So I have a division problem here. So the opposite of divide is to multiply. So I'm going to multiply by the denominator, which is 6 over 1, and multiply 7 by 6 over 1. 6 over 1 times x over 6. These 6's cancel out. You simplify before you multiply, and you get x is greater than or equal to 7 times 6, because 7 as a fraction is 7 over 1. 7 times 6 is 42. So I find 42 on my number line, and I put a circle around it. I look at my inequality, greater than or equal to. Since it's equal to, 42 is a solution, so I color in the circle, I shade it in. X is greater than or equal to 42, so I need all numbers greater than 42, which is 43, 44, and 45. So my number line, my arrow is going to go to the right to show all numbers greater than 42.